Sometimes pi shows up in the most unexpected places. In this video, we're going to explore a simple experiment to discover pi in your own home. All it takes is a skewer, hardwood floor, and some patience. Step 1 is, of course, to find some hardwood floor. Or just make your own. For this experiment, what we need is a large surface with many evenly spaced lines. Hardwood floor is ideal for this, but if that's not an option, then Bristol board with lines drawn on will work just as well. Next, we're going to cut the skewer to size. Its length needs to be exactly the distance between two adjacent lines. Now we're getting to the fun part. Step 3 begins with tossing our newly cut skewer high in the air so it lands randomly on the surface. There are a couple of cases to consider for when the skewer comes to rest. It may end up crossing over one of the lines, like so. In this case, we're going to make a tally noting that the skewer did cross a line. On the other hand, it might land between two lines such that it doesn't touch either of them. If this happens, we're going to make a tally noting that the skewer did not cross a line. Step 4 is to simply repeat this toss and tally process. A lot. To get a meaningful result, we should do at least 100 tosses, but the more the better. When done tossing, it's time to add up the results. For this demonstration, I did 300 tosses in total. 185 times, the skewer crossed a line, and 115 times, it didn't. Now we're going to calculate the proportion of tosses where the skewer crossed a line. In our experiment, the skewer crossed 185 times. This was out of a possible 300 tosses. Doing this division gives a 0.617, meaning the skewer crossed a line 61.7% of the time. Knowing this, we're now very close to getting our final answer. Let's take 2 and divide it by the number we just calculated. The answer we get? 3.24. And this is our value of pi. You may be thinking right now, well, wait a minute, isn't pi supposed to be 3.14? And you're right, but this method can only give us an estimate of pi's true value. That number we used was based on that for our particular experiment, the skewer happened to cross 185 times. But this was all due to chance. Isn't it possible that if we did another 300 tosses, the skewer might cross a few more? Or a few less times? So this value is only approximate. Incredibly though, if we were to continue the experiment for thousands, or millions of tosses, it would get closer and closer to the exact value of pi. That means 2 over the probability of the skewer crossing a line, which we'll call p, is exactly pi. or rearranging, the probability is exactly 2 over pi. Isn't that kind of amazing? How an experiment as simple as repeatedly tossing a skewer is somehow connected to one of the most important constants in math. It's a bizarre yet sort of beautiful relationship. But why does it work? There must be a reason for the probability being exactly 2 over pi. And indeed, there is, though it's not obvious. I will post a video soon on how to solve this problem. In the meantime though, if you're feeling inspired, break out a pen and paper to see what you can figure out yourself. A good starting place is to consider how likely it is for the skewer to cross if it lands perfectly parallel, compared to if it lands perfectly perpendicular to the lines.